Let's solve this question over here. Find the angle in radian through which a pendulum swings if its length is 75 centimeter. Okay, and what else? Tip describes an arc of length 10 centimeter or 15 centimeter, 21 centimeter. That's the question in front of you. Now, what does a pendulum look like and what does a pendulum do? A pendulum would be a fixed rod, which is rotating about this particular point, let us say, and this is the ball at the end of the pendulum. This ball would be rotating in this manner and this pendulum would be swinging between 2 points like this. Between these 2 points, the pendulum would be swinging tuck, tuck, in this manner, right? It will be swinging over here. And the arc that it will describe, this arc will be actually a circular arc, right? This circular arc will be part of obviously some circular path in this manner, right? And let us say the arc length is L. Let us say the arc length is L. This radius is R. Okay. And if this angle is theta, then you may observe that in the circular path, this L will be equal to R theta. For the circular path, L would be equal to R theta, where theta is in radians. Okay. The person has asked us to find the radian only, the angle in terms of radians only. And it is given that R equals 75 centimeter. R is the length of this rod, right? This length of this rod is 75 centimeter. Okay. And the tip describes an arc of length. This length is 10 centimeter or 15 centimeter or 21 centimeter. Those are the three parts. Let's talk about the first part. L equals 10 centimeter. Okay, if L is equal to 10 centimeter, that gives me, therefore, theta would be equal to L upon R, which gives me theta is L, which is 10 upon R, which is 75. This is what you get. And 5 times 2, 5 times 15. This is what you get. This is 2 upon 15. Now, what is that further equal to? This can be simplified as this is, therefore, theta is equal to 2 by 15 radian. Or it can be written as, or in terms of decimals, if we go, this is 0.15 times 1 is 20. Okay, 15 times 1 is 25 gets carried. 15 times 3 is 45. Then 5 gets carried, and 15 times 3, 0.133 dot. This is what you get. This is 0.13 bar radians, right? This is what you get. That's the value in terms of radians, or you can simply say 2 by 15 radians. What else? Let's talk about the second part after this. L is given to be, in the second part, L is 15 centimeter. So if L is 15 centimeter, therefore theta would be equal to what? Theta can easily be found using this result over here. Theta equals L over R. What is that equal to? L is 15 over R is 75, right? 15 over 75 is what I get. Now what does that give me? This is 1 over 5 simply, which gives me theta is equal to 0.2 radian. 1 over 5 or 0.2 radian. That's the value of theta in the second part, right? What about the third part? In case of third part, what is given is L equals 21 centimeter is given. Therefore, theta would be equal to, again, using this result over here, theta would be equal to L upon R. L is 21 centimeter. R, as you may recall, is this 75 centimeter over here. L is 21, this is 75, and this ratio would be equal to what? You can cancel by a factor of 5, you will get 7 upon 25. This is 7 upon 25 radian, or 7 upon 25 can further be simplified. Division by 25 is not a difficult thing, you can always do that. Multiply this numerator by 4 and put a decimal after 2 places from the right. This is 0.28 radian. That's my answer for this third part over here. This is the final solution for this complete question, as you can see behind me, right? That is all in this question. And with this, we have reached the conclusion of this exercise 3.1 based on trigonometric functions of NCERT class 11th. In the next session, we'll be talking about another exercise. Till then, all the best.